Okay, this is 3.1. This is your video lecture. In the middle of it, I'm going to ask you to pause and do a quick problem. So here we go. So 3.1, you previously learned how to find the determinant of 2 by 2 matrices, and this was you multiply A times D, and then you subtract B times C. So in this section, you're going to learn how to find determinants of larger matrices, 3 by 3s, 4 by 4s, etc. So we need to introduce some new notation, and this is for given a matrix A subscript ij is just a submatrix you get by deleting row I and column j. So for this matrix here, A, if I want to do this submatrix A2, 3, that means I want to delete row 2, column 3. So take out row 2, column 3, and the submatrix that you end up with is 2, 0, 4, 3, 1, 2, 5, 2, 0. And if I wanted to do A 4, 2, that means delete row 4, column 2. So if we take row 4 out and column 2 out, excuse me, you're ending up with the matrix 2, 1, 0, 0, 4, 3, 5, 6, 2. All right. So then with that particular notation, we can now introduce the definition of the determinant of an n by n matrix, and it could even apply for 2 by 2s. Is what you do is you take the sum of the n entries of the form plus or minus A1j. So you're going to be alternating the signs plus, minus. And it's just the determinant of A is you take the first entry, take the first entry and then multiply it by the determinant of the submatrix you get by deleting row 1, column 1, and then you do minus the next entry, and then you do it times the determinant that if you remove row 1, that column 2, and you work your way down. So here's an example. I'm going to do it using this crazy notation. Eventually, I'm going to show you how you can get away from having to use the notation. But for this one, the determinant of A, if this is matrix A, using this notation, this is minus 1 to the 1 plus 1 times A1, 1 times the determinant of A1, 1 plus minus 1 to the 1 plus 2 times the determinant of A1, 2. Oops, excuse me. I am missing. This should be A1, 2, little A1, 2. The determinant of the submatrix A1, 2 plus minus 1 to the 1 plus 3 times A1, 3, little A1, 3 times the determinant of the matrix sub 1, 3. And I've got copies of the matrix down here below. So let's pay attention. Do you see this is minus 1 to an even power? So this is plus 1. This is minus 1 to an odd power, so it's minus 1. This is minus 1 to an even power, so it's plus 1. So up above, they were talking about the signs alternate, plus and minus alternating. So do you see you get plus, minus, plus? And then you're just going to be you're going to be working away the top row. And so this is A1, 1. This is A1, 2. This is A1, 3. And so you're going to have the plus 1. So I don't need to write the plus 1. And A1, 1 is 3. And then you want to do it times the determinant of the matrix you get if you delete row 1, column 1, and the determinant of the matrix 3, 2, 5, minus 1. And then you're going to have a minus because of this minus, and it'll be the determinant of the submatrix if you delete row 1, column 2. The submatrix you get is 2, 2, 0, minus 1. And then now you're going to get plus. And in this case, you now have to multiply by 4 times the determinant. I should put the 1 in here just as a reminder that it is a 1. And then you want to do the determinant of the matrix if you delete the row and column that 4 appears in. So 2, 3, 0, 5. And now these are determinants of 2 by 2's, which you've learned how to do. So this is 3 times negative 1 is negative 3, minus 2 times 5 is minus 10. And this will be minus 1, so you don't need to do anything because it's 1. 2 times negative 1 is negative 2. 0 times 2 is 0. Plus 4 times 2 times 5 is 10. Minus 3 times 0 is 0. So you get 3 times negative 13. This becomes minus 2, so that's plus 2. This becomes 4 times 10, so you get 40, or negative 39, plus 2, plus 40, which is equal to 3. So let me do one more example. This time I'm just going to pay attention to, do you realize the sign pattern is going to be plus 1, minus 1, plus 1. So plus, minus, plus. And I'm going to be using these entries. So I'm going to have a plus 2 times the determinant of the submatrix I get, minus 2, 5, 0, minus 3. Then the second entry, so I need a minus 1. Be careful with that, because remember it's minus 1, times the determinant of 3, 1, 5, minus 3. That's the submatrix I get if I delete this row and this column. I get that 3, 1, 5, negative 3. Now I'm back to plus. And if I go down to the next entry, which happens to be 4, times the determinant of the submatrix that I get if I delete the top row and the third column, I have 3, minus 2, 1, 0. So this gives me 2 times negative 2 times negative 2 is positive 6. 5 times 0 is 0. I see minus gives me plus. 3 times negative 3 is negative 9. Minus 5 times 1, which is 5. Plus 4 times 3 times 0 is 0. Minus a minus 2 times 1 is a minus 2. So I have 2 times 6 is 12. This is minus 9 minus 5 gives me minus 14. And this is negative 2 is positive 2 times 4 is 8, which gives me 6. So the determinant of A is equal to 6. So now there's some alternative notation for determinants. So determinant of A can also be written with this absolute value bars. So for the example I did above, the determinant of 2, 3, 1, minus 1, minus 2, 0, 4, 5, minus 3, we figured out was 6. So I'm going to be using that alternative notation quite often. And in your homework, you're going to see the alternative notation. All right. So now here's another definition, and this is this thing called cofactor. And all this is if we take, come on you, there we go, sorry, minus 1 to the ij, and then determinant of that submatrix ij. So notice in the definition for determinant, the cj are these two pieces right here. So we can write this, the determinant of A is just J goes from 1 to N of A1J times that cofactor. In this case, it would be 1J. So that's just called cofactor. So if we're doing this here, it turns out there's this theorem that says the determinant of an n by n matrix can be computed by a cofactor expansion across any row or down any column. It doesn't have to be just across the first row. And if you go across the ith row, what you're doing is you're fixing the row, which is what we did the first time. We fixed it, I was 1. But we could do 2, we could do 3. Or we could fix the column. So this is just saying we can find determinant of A using any row or column, not just the top row. So let me do a determinant going down a column. Here's an example. Find the determinant down column 2. So this is going to be column 2. So we're going to do this one. So in this case, the determinant of A, this is matrix A, is we are going to fix column 2. And then we're going to let the J's go from 1 to 3. So I have 3 copies of this matrix. I'm going to do each part. So this first one is I need A1, 2, C1, 2. So this is going to be A1, 2 is 1. And then C1, 2 is minus 1 to the 1 plus 2. That's that cofactor part. And then we're going to do it times the determinant. I'm going to use the alternative notation. We want to delete that row and that column that 1 appears in. So this is 2, 0, 2, minus 1. And then now let me look at A22, C22. So this says there is A22, which is 3. Then the cofactor is going to be minus 1 to the 2 plus 2. And then the determinant of the submatrix. So I want to delete the column in the row that entry appears in. So 3, 0, 4, minus 1. And then I need the final one is A23, C23. And that entry, A23 is 5. That cofactor is going to be minus 1 to the 2 plus 3. And then the submatrix that I have is if I delete the row and column that entry appears in, 3, 4, 2, 2. So once again, I'm going to go ahead and pay attention to these signs. So notice here the power is an odd power. So this is a minus 1. And for the next one, you see I have an even power. So this is a plus 1. And for this next one, it's an odd power. So this is minus 1. So do you see when I start down this column, it's a minus 1, plus 1, minus 1. So it's going to start with a negative and then just going to alternate plus, minus, plus, minus. So now putting these together, oops, make a little bit, there we go. So we can see it all at the same time. What I'm going to have is for the determinant of A, this ends up being minus 1 times the determinant of 2 times negative 1 is negative 2 minus 0. Now the next one you see is a plus 1, so I get plus 3. And then the determinant here is 3 times negative 1 is negative 3 minus 0. and then I'm going to have a minus times 5, and then this is 3 times 2 is 6, minus 4 times 2 is 8. So this gives me a positive 2, a minus 9, and this is minus 2, so I get positive 10, which gives me 3. So you see we got the same value for the determinant by going down column 2. So I'm going to comment about the sign pattern right now. And this will come into play when you're using any particular row or column. It's either going to start with +1 and then go +1 minus plus minus plus, or it's going to go minus first and then minus plus minus. It's going to always alternate. So let's just look at, we have the J's. We have 1, 2, 3, 4, and then the I's, 1, 2, 3, 4. So remember, this is minus 1 to the 1 plus 1, minus 1 to the 1 plus 2, minus 1 to the 1 plus 3. So do you see I end up minus 1 squared is a positive 1. Then I have minus 1 to the odd power is minus 1. Then I have minus 1 to an even power. So you see on that top row it goes plus, minus, plus. Now if I go to the next row, this is minus 1 to the 2 plus 1, minus 1 to the 2 plus 2, minus 1 to the 2 plus 3. And so this is minus 1 to an odd power is minus 1. Minus 1 to an even power is plus 1. Minus 1 to an odd power is minus 1. If I go to the next row, I'm going to have minus 1 to the 3 plus 1. Minus 1 to the 3 plus 2. So this way is going to be minus 1 to an even power. So plus 1, minus 1, plus 1, minus 1. So do you see this top one is always a plus, and then it alternates plus, minus, plus? Now, do you see going down this column, do you see this is minus, plus, minus? So if you pay attention to this alternating sign, when I did the first one, I had row 1, so I had plus 1, minus 1, plus 1. When I went down column 2, I did minus, plus, minus. So if you keep that in mind, you can bypass having to do all of these work for those and just notice that sign pattern. So now I'd like you guys to try and pause the video, and then on My Open Math, do these 2 problems. And when you're going to be doing these problems, it's going to be scaffolded, so you have to show your steps in between. So you'll see something like this, and you'll have 4 entries here, plus something here, 4 entries here, plus something here. So this entry right here, this is that minus 1 to the I plus j, a ij, and just simplify it. And then this is the submatrix. So basically I want to see if you can set it up correctly. And this is going to be doing across the top row. So you're going to be filling it all in, and then the second step you'll be finding the different values, then finding the values for these determinants, and then finally calculating the actual determinant value for the matrix. And then the second one is asking you to go down column 3. So I'd like you to try those. And I'll pause. All right, well, hopefully you were able to do it on your own. If not, feel free to come see me. And I'm happy to help you. So let's look at this matrix. And we want to find the determinant of this matrix A. And I'm going to choose a convenient column. And so I'm going to choose column 1. And when I look at this, using column 1, not row 1, remember, it doesn't matter which row or column I pick. And I notice the sign pattern, it's going to be plus, minus, plus. So I see I'm going to have plus 2, minus 0, plus 0. And then I have the determinants of my submatrices. So this is going to be 4, minus 2, 0, minus 3. This will be 0, 0, minus 2, minus 3, and 0, 4, 0, 0. But notice Who cares what this is? Because I'm going to be multiplying it by 0. So ultimately, this is just going to give me a 0. Similarly, this one. Who cares? Because I'm going to be multiplying it by 0. So this is just a 0. And this one over here is 2 times 4 times negative 3 is negative 12 minus 0. And so I get the determinant of A is equal to negative 24. So it's good advice. Choose a row or column with the most zeros. That means you're going to have less work, because when you're multiplying, but when one of the entries is a 0, we don't even need to figure out what the determinant of the submatrix is, because you're going to ultimately multiply it by 0. Note, we could have also used row 3 above as well. So column 1 and row 3 both have only one non-zero entry. But that's sort of when you're doing this by hand, conveniently look if there's any rows that have lots of zeros or any column with lots of zeros. Choose that one. Okay. So now triangular matrices. A quick definition, a triangular matrix, this is a square matrix. Remember, that's where they have the same number of rows and columns. And this is where all the elements either below or above the diagonal are all zeros. And there's two types. There's an upper triangular that looks like this. So do you see it creates a triangle on the top, or a lower? Do you see how I get a triangle on the bottom? And what's happening is all of the entries, all of those entries on this side, you see these are all zeros. So all of these entries are zeros. And on the lowers, do you see all of the entries on that side? So all of these entries must be 0. Now the other entries that form the triangle, some of those could be zeros. That's okay. But what you have to have is everything on the other side of the diagonal, those entries must all be zeros. And when you have a triangular matrix, it turns out that it's really easy to calculate the determinant. And for those matrices, finding the determinant is all you have to do is multiply the entries on the main diagonal. So you see this one is an upper diagonal matrix, upper triangular matrix. And so according to this theorem, the determinant of A is just 2 times minus 1 times 3 times 5, which is going to give you negative 30. So now let me show you, by doing it the long way, that this is why we end up with it working this way. So we're going to demonstrate using the definition. We'll do the long way, and I'm going to once again do column 1. So in this case, it's going to be, remember I have plus, minus, so it's going to be positive 2 times the determinant of the submatrix, which is minus 1, 4, 0, 0, 3, 5, 0, 0, 5. And then I'm going to have minus 0 by some matrix determinant. Oops, this shouldn't be a matrix, by the way. Sorry, this should be determinant, not a matrix. This, who cares? Because I'm going to multiply by 0. 0 times, who cares? I don't even care what this thing is, because I'm ultimately multiplying the determinant by 0. Minus 0. Who cares? So when I pick 0, 0, 0, I don't care. So I'm not going to do that work. So all of these are just going to be 0, 0, 0. So then now let's look at the determinant of this. So now this is a 3 by 3 matrix. So when I want to do this 3 by 3 matrix, and I want to find its determinant, I'm going to choose the first column for that. So to find this one's determinant, and this is a separate 3 by C plus minus plus. So this is going to be plus a negative 1, so I'm going to have negative 1 times the determinant of the submatrix, 3, 5, 0, that's a 5. So in turn, I end up with 3 times minus 1, and then this gives me 3 times 5 minus 5 times 0. And lo and behold, we have that 2 times minus 1 times 3 times 5. And this is why, hopefully you see, why multiplying down the diagonals for triangulars. This is just the product of the diagonal entries. Alrighty. So I hope this helps, and I'll see you guys on Monday.